Lesson 5.2, Day 1, the majority of this lesson is going to be dealing with graphing quadratic functions. So we're going to be learning how to graph quadratic functions and some of the terminology that goes with it. So the first thing we want to be able to identify is the axis of symmetry. The axis of symmetry is the x-coordinate of the vertex, and it's the line that splits the parabola into two equal halves. If the equation is written in vertex form, it's going to be the opposite of whatever's in the parentheses with x. So you can see here's the axis of symmetry, and it divides the parabola into equal halves. You can see that each of those are 1 unit away, and as we continue to go through the parabola, everything will be equally spaced apart on both sides. Example 1, identify the axis of symmetry. This equation is in vertex form, so the axis of symmetry is going to be the opposite of whatever's in the parentheses with x. So in this case, the axis of symmetry is -5. In this one, there is nothing in parentheses with x, so this is kind of like this, even though we wouldn't write the +0. So the axis of symmetry on this problem is, because there's nothing there, it's 0. So if functions are in vertex form, we can easily identify the axis of symmetry, and if they're not, then they would be in standard form, where you have either f of x or y equals the function ax squared plus bx plus c, and then we would do something different to find the axis of symmetry here. To find the axis of symmetry here, it's going to be the opposite of b over 2a. Some other things to look at is if a is positive, then the parabola will open up, and if a is negative, the parabola will open down. And we'll see that as we're graphing. Once we find the opposite of b over 2a, once we find that x value, we would plug it back into the function to get the y value, and that would be our vertex. And then it says that the y-intercept is c. So this is all of your steps for graphing right here, pretty much. Example 2, graphing quadratic functions in standard form. So now what we're going to do is we're going to find some specific points, and we're going to graph those points and then reflect it over the axis of symmetry to graph these quadratic functions. So this list of questions is kind of a guide on how to do this problem. So the first thing that I like to do is identify my a value, my b value, the opposite of b, and c. So the a value is 2. The b value is -4, and the opposite of -4 is +4, and the c value is 5. So a is +2, b is -4, the opposite of b is +4, and c is 5. We're going to use all of these values to help us graph. So now that we've identified those, we're going to use the a value to determine if it opens up or down. Since a is positive, it's going to open up. So that means we should have a parabola. I don't know exactly what it's going to look like, but it'll open up like that one. Find the axis of symmetry. That's going to be the opposite of b over 2a. So right here, opposite of b over 2a, and that's for this question. So the opposite of b is 4, and then we're going to divide by 2 times a. That's going to be 4 divided by 4, which is 1. So the axis of symmetry is right here at x equals 1. So I know that my parabola will be reflected across that line right there. Now that I know the axis of symmetry, I've got to find the vertex. To find the vertex, we plug this in, since that's an x equals, we're going to plug that into the original equation. So we will have 2 times 1 squared minus 4 times 1 plus 5. And that's going to be 3. So our vertex is 1, 3. So if we go over to 1 and up to 3, that's the vertex of the parabola. Now it says find the y-intercept. The y-intercept is C. To write that as an ordered pair, it's 0, 5. Because it's the y-intercept, 0, 5. So now that we've got 2 points, we need a third point to make a good parabola. So, and that's what it says right here. Do you need another point? It'd be better to have 3 points than it is to have 2. So now we're going to choose another point. We can choose any point we want, and typically it's either -2, -1, 0, 1, or 2. Now, since we started graphing and the parabola is going to the left, I'm going to choose this next point at the left, which is -1. So I'm going to put -1 in the function. 2 times -1 squared minus 4 times -1 plus 5. When I simplify this, I get 11. So our next point is -1, 11. So now we're going to reflect these points over. We're going to take the blue point and reflect it over the axis of symmetry, and it's going to be right there, 2 away from the line. The red point's 1 away from the line, so we're going to reflect it over 1 away. And now we can connect this with a smooth curve, and there is our parabola. Okay, this problem is going to be done the same way. We have to identify our A, B, and C values. And then once we do that, we can go through the questions. So A is -1, B is -2, the opposite of B is +2, and C is 3. A is negative in this case, so that means that the parabola will be opening down. So it's going to look like this, but we'll go through and find the specific point so we know exactly what it looks like. The axis of symmetry is the opposite of B over 2A. So the opposite of B is 2 divided by 2 times A. So the axis of symmetry is -1. Now we're going to plug that into the equation to find the vertex. So be careful here because it's a negative x. It'll be negative, and when we substitute x in, that's also going to be negative. -2 times x plus 3. So that's going to be -1 plus 2 plus 3, which is 4. So our vertex is -1, 4. The C value is our y-intercept. And as an ordered pair, it's 0, 3. When we reflect that point over, it's going to be right here. So now we either want to choose -3 as our next point or +1 as our next point. So we want this to be, we want a good picture, so that's why I have to pick one more point. I'd rather use a positive number than a negative, so I'm going to put 1 into the equation. So we will have -1 squared minus 2 times 1 plus 3. And when I simplify this, I get 1, 1, 0. So there's my next point. Reflect that over. Draw a nice smooth U-shaped curve, and there's our parabola. Okay, one more problem to go over, and this is a good problem because we don't always have B and C values. We have to have an A value, otherwise it's not a quadratic function, but sometimes we don't have B or we don't have C, and that's okay, it's just 0. So here A is -2, B is -4, and C, well, let's do opposite of B. opposite of B is 4, and C is 0. A is negative, so this one opens down. The axis of symmetry is the opposite of B over 2A. So the opposite of B was 4 over 2 times A, which was negative 2. That's 4 over negative 4, which is negative 1. So our axis of symmetry is right here at negative 1. Plug negative 1 into the original equation to find the vertex. So our vertex is negative 1, 2. The y-intercept is our c value, and c is 0, so that means our y-intercept is 0, 0. Reflect that over. And now I want to choose another point. I can either choose positive 1 or negative 3, because that's the next point left and right of my parabola. I'm going to choose positive 1. So we have negative 2 times 1 squared minus 4 times 1, and that's going to be negative 6. So our next point is 1, negative 6. Reflect this over, and then now we can graph a nice smooth curve, try and make it U-shaped versus V-shaped, and there's our quadratic function. Okay, that's it for today's lesson.